Very good morning to all of you. Before going further, let us make quick review about the previous lecture. You may have the experimental data may be given in the form of the table. Let's denote the x0, x1 and so on xn. These are called the nodes at which at these points you are going to have the values y0, y1 and so on yn, and this second row is called ordinates. So this may represent some function f of x, which you may or may not be aware about it, but due to some experiment you come up with the following table. You wish to fit the data into a smooth curve, okay, so by means of interpolating polynomials. So what we have learned in the previous lecture, that if these nodal points are distinct, so if x0, x1 and so on xn are distinct, then there exists an interpolating, there exists a unique interpolating polynomial say p of x of degree at most n. So we have learned this result, that there exists a unique interpolating polynomial. So we observe that there will for the same interpolating polynomial there may be different type of representations. So we have learned two type of representations there. One was Lagrange's form, by definition what it is p of x is equals to summation yj lj of x, where j is running from 0 to n. So where Lj of x are called cardinal functions. Lj of x is equals to product of I equals to 0 to n, I not equals to j, x minus xi divided by xj minus xi. So where j is running from 0 less than equals to j less than equals to n. So another form of interpolating polynomial what we have learned was Newton's form, which is given by p of x is equals to, if I wish to write in compact form, that is summation j equals to 0 to n cj time product of x minus x I is running from 0 to j minus 1. Here we have the convention that, so we are assuming that product of I equals to 0 to m x minus xi is equals to 1 if m is less than 0. Okay, so because j equals to 0, it's running from I equals to 0 to minus 1. So we have the following convention, or you can write it as C0 plus summation j equals to 1 to n, Cj product of I equals to 0 to j minus 1 x minus xi. So here what are now Cz's? So Cz's are also obtained in terms of divided difference formulas. So if I wish to rewrite them, so let's recall what is C0 was is f of x naught, which we have denoted by f with this box bracket, and which is called zeroth divided difference. In short, d dot t dot. Now the next C1 was, if you recall from the previous lecture, that was f of x1 minus f of x naught divided by x1 minus x naught. So C1 is clearly depending on x1 and x naught both. So this is denoted by f of x naught comma x1, which is called the first divided difference of f. Now similarly, if you go for C2, that will be f of x1 comma x2 minus f of x naught comma x1 divided by x2 minus x naught. So if you recall the previous lecture, it was this, and which is clearly depending on x naught, x1 and x2, that can be verified easily that this is equals to f of x naught comma x1 comma x2 in terms of the box brackets. So this is called second divided difference. Indeed, we have given the formula for higher order divided differences, so which is given by Cn, which is clearly depending on x0 to x1 and so on till xn, that was given by f of x1 to xn minus f of x0 to xn minus 1 divided by xn minus x0. Right? So this is higher order divided difference, or you can say this is nth order divided difference. Now if you calculate them like this separately, that is too tedious job. On the other hand, if you do the same thing with the help of table, that is going to be very simple. So let's compute a divided difference table for these functions values. Then further write the Newton interpolating polynomial for the same. So let's compute the difference table. So let me write in the table form. So let's say this is x, this is y. Okay, so what are the values? 3, 1, 5, 6 for x, and for y what are the values? 1, minus 3, 2, 4. 1, minus 3, 2 and 4. Now we wish to calculate all possible first divided differences. Okay, divided difference table we try to compute first divided difference, second divided difference, and so on. So look at here. So this is the zeroth divided difference. If you recall, this is what is this is x naught. So this is f of x naught. So zeroth divided difference is rightly here at the starting of the y table, y column. Okay. Now for first divided difference, so this is your f of x naught. Okay. So if you see, so this is your f of x naught, which I call, maybe you can say f naught. I will call it as f naught. This is f1, this is f2, this is f3. Okay. Now if we use the following notations for f of x naught, f of x1, f of x2, f of x3, this is x1, this is x2, and this is x3. If I use this, so, and if you go back and check, so if you see here C1, okay, C1, this is nothing but f1 minus f naught divided by x1 minus x naught. Okay, right. So once if you go for it, so f1 minus f naught, so we are going to use the both things here. So you are going to have, this is f1 minus f naught divided by x1 minus x naught. If you calculate this value, so that is 3 minus 1 is 2, divided by 1 minus 3 is minus 2. So 2 divided by minus 2 is minus 1. Okay, right. Now for getting the second divided difference, this is the column for second divided difference. Okay, you need as well as this and the first divided difference of the next, if you recall from the previous formula. So let's calculate the following. So you are going to use this and this. So the next here is f2 minus f1 divided by x2 minus x1. So that is equals to 2 minus 3 divided by 5 minus 1. So 2 minus, okay, so here we have, this is wrong here. So this is not minus 1, since this is here is f1 is minus 3. Okay, f1 is minus 3. So minus 3 minus 1 is minus 4. Divided by 1 minus 3 is minus 2. So minus 4 divided by minus 2 is, so minus 4 divided by minus 2, that is equals to 2. Okay, now this is here 2 minus minus 3, that is 5. Divide by 5 minus 1 is 4, 5 by 4. Now below the another first divided difference here is 4 minus 2, or say f3 minus f2 divided by x3 minus x2. So that is equals to 4 minus 2 divided by 6 minus 5. So that is equals to 4 minus 2 is 2, 2 by 1 is 2. Okay, right. Okay, right. Now, so this is up to here is first divided difference only. Now we wish to calculate second divided difference. So this is, if you see what is this, first here is f of x naught comma x1. What is this is f of x1 comma x2. And if you look at the last is f of x2 comma x3. Right? Now, so we are going to now go for second divided difference for there. Now second divided difference means So here we have calculated, so this is your C1. C0 is already calculated, that is f of x0. Okay, right. Now for calculating C2, you have to calculate second divided difference, that is f of x0 comma x1 comma x2. Right. Now to go further, again you are going to use these two values here, and you will get some value here, and you are going to calculate one more for 2 here. Right. So this is equals to, so second divided difference is, if you recall, f of x1 comma x2 minus f of x0 comma x1 divide by x2 minus x0, and for this next case is f of x2 comma x3 minus f of, so f of x2 comma x3 minus f of x1 comma x2 divide by x3 minus x1. Right. So if you recall, what is this here is, if you recall, this is nothing but f of x0 comma x1 comma x2, second divided difference. And if you recall this by using the formula, if you recall this, what is this is f of x1 comma x2 comma x3. Right. So what we have observed, so let's make clear table here. So you have observed, this is x, this is y. So you have 3156, let's say 3156, 1 minus 324, 1 minus 3 2 4. Right. So first divided difference is are 2 5 by 4 and 2. Then second divided difference, what we have observed was, if you calculate these ratios in the second divided difference table, that is 5 by 4 minus 2, that is 5 by 4 minus 2 divided by 5 minus 3. So that is equals to minus 3 by 8. And here the next is here 2 minus 5 by 4 divided by 6 minus 1. So that is equals to 3 by 20. Right. Okay. Now hopefully you get the flow here. So for third divided difference now, so if I wish to link all the things here, so to get the first divided difference, I have used this value for getting 2. I have value for by 4, I am getting this, and for getting here, this is here. Okay. Right. Now for getting second divided difference, we have make use of these two values and these two values. Now for the third divided difference, we are going to use these two values. So that is 3 by 20 minus 3 by 8 divided by 3 minus x naught, that is 6 minus 3. If you recall from the formula higher order divided difference, that is equals to 7 by 40. Right? So this is C1. If you look it here, okay, then C2 is given by this, C3 is given by here, and that is your C4. So the Newton's interpolating polynomial will be P of x is equals to C naught plus C1 times x minus x naught plus C2 times x minus x naught into x minus x1 plus C3 times x minus x naught times x minus x1 times x minus x2, right, with the help of these 4 points, okay, 3, 1, 5, 6, x0, x1, x2, x3. Now C naught is f of x naught plus C1 is f of x naught comma x1 x minus x naught plus C2 is f of x naught comma x1 comma x2 time x minus x naught time x minus x1 plus C3. What is C3 is? Plus f of x naught comma x1 comma x2 comma x3 time x minus x naught into x minus x1 into x minus x2 for the given table. So all the different divided differences are known now. So that is equals to, so C naught is f of x naught, that is 1 from the table, okay, from the table 1, this is f of x naught, so that is 1 plus f, so first divided difference is 2, so we have to look in this direction here, okay, so to get the all the divided differences in the sequence, so C naught, C1, C2, C3 all will be given by this, okay, in this arrow, in the descending order you can see, okay, or downward direction you can see, starting from the y below point, that is 1, and you are going in the downward direction, okay, right. So C2 is 2 times x minus x naught is 3, so x minus 3 plus second divided difference was minus 3 by 8, so that is minus 3 by 8 times x minus x naught into x minus x1, that is x minus 1 plus C3, that is 7 by 40 plus 7 by 40, so that is 7 by 40 into x minus 3 into x minus 1 into x minus x2, x2 is 5, so x minus 5. So this will be the corresponding Newton's polynomial. Okay, so for better understanding, let us take one more example here. Okay, let's make one more example. Okay, so construct a divided difference table for the following data. So let's take the data are, let's say, -2, -1, 0, 1, 3, 5. Let's say this is y points are, let's say 0, 1, 2, 17, 8, 6, 7, 67, and write the corresponding, or write the Newton's polynomial. Okay, so we will directly write now the divided difference table, and we will directly try to extract all the divided differences in a sequence. Okay, right. So let's have here, so you have, this is x, this is y. So what are the values for x? Is -2, -1, 0, 1, -2, -1, 0, 1, 3, and 5. What are the y values? 0, 1, 2, 17, 0, 1, 2, 17, 8, and 67. So C0 is readily given here. Okay, that is f of x0. Now, first divided difference, first order, you can say first order divided differences. So the y column is 0th order divided differences. Okay, right. Now first order divided differences. So for writing the first entry here, so you are going to use this and these two values. So that is going to be 1 minus 0 divided by -1 minus -2, that is equals to 1. Now for the second entry, you are going to use the following two entries, that is 2 minus 1 divided by 0 minus -1, that is equals to 1. Okay, so what we are following? So if you look at back, the first entry is, so this is f0, this is f1, this is f2, f3, f4, f5. Okay, so f1 minus f0 divided by x0, x1 minus x0. So for the second entry, you have f2 minus f1 divided by x2 minus x1. For the third one, third entry, you have f3 minus f2, that is 17 minus 2, divided by x3 minus x2, that is 1 minus 0, so that is equals to 15. Now for the fourth entry, you have, this is 8 minus 17 divided by f4 minus f3 divided by x4 minus x3, that is 3 minus 1. So that is equals to -9 by 2. Now for the last entry is 67 minus 8 divided by f5 minus f4 divided by x5 minus x4, that is 5 minus 3. So 67 minus 8 is 59 divided by 2. So these are the corresponding first order divided differences column. Okay. Now next go for second order divided differences. Now note that you have the data set of n plus 1 points, then you are going to have a degree a polynomial of degree at most n. Okay, so you are going to get divided differences up to order n. So nth order divided differences. So here is x5. So it's going to be possibly at the degree of the polynomial is at most 5. Okay, at most 5, right? So we are going to get C0, C1, C2, C3, C4, C5, right? Okay, so we are in the process for getting the second order divided differences. So it's going to be, so this is here, so you are going to use these two values, so that is 1 minus 1 divide by, so here you have to leave one here, means you have to leave one step between. Okay, so if you say, I wish to say what is going to be in the denominator for this, you are going to skip this, means you are going to make the going for this here. So in this interval, length of this interval 0 minus minus 2, not length but the difference. Okay, this 0 minus minus 2, so that is equals to 0. Now for this, for the next case, you are having 15 minus 1 divide by, what will be the denominator is going to be the not this, you are going to have the following interval. So you have 1 minus minus 1, that is equals to 14 by 2, that is 7. Now for this and this, for the next entry, so you have minus 9 by 2 minus 15 divide by, you have this and this here, this interval. So 3 minus 0, so that is equals to minus 39 by 6, right? Now for the next or last entry, means you have 59 by 2 minus 9 by 2 divided by, so you are going to use 1 and 5, this interval. Okay, so this is equals to 5 minus 1, that is equals to 59 plus 9 is 68 by 2, that is 34 by 4, that is equals to 17 by 2. Right? So you are so here in the denominator you have to also be cautious here. Okay, so denominator in the second order divided difference, you are skipping, you are starting from the minus 2, then you skip minus 1, so minus 2 to 0, so 0 minus minus 2. Okay, for the second entry you are going to with the next value, so x0, then x1 to x3, then x1 to x1 and x3 minus x1. Okay, so this is in the denominator, if you look, that is x2 minus x0 here, here is x3 minus x1 in the denominator, here is x4 minus x2, and here is x5 minus x3. Okay, so you are going with skipping 1. Okay, right. So now it becomes easy to create a divided difference table. So let's go for third order now. Third order divided difference. So you are going to use these two. So 7 minus 0. Now you are going to skip 2. Okay. So x0, x1, x2, x3. Okay. So you are going to with x3 minus x0. That is 7 divided by x3 minus x0 is 1 minus minus 2. So that is 3. Right. Now for the next, minus 39 by 6 minus 7 divide by, now x1 to x1, x2, x3, x4. So x1 to x4. So you have x4 minus x1. You are skipping 2. So that is equals to 81 by 6 into x4 minus x1. So that is 3 minus minus 1, that is 4. So minus 81 by 24. Now for the next entry, you are going to have, this is 17 by 2 minus 39 by 6. So you are going to start with x2. Okay, so x2, x3, x4, x5. So x5 minus x2 divided by x5 minus x2. So that is equals to 90 by 6 into x5 minus x2, 5. Right? So what we have is, so let me write down. So note that in the first order divided difference, you have not skipped any of the value of x, right? x1 minus x0, x2 minus x1, x3 minus x2, and so on. In the second order divided difference, you have skipped the 1 in between. So you have, first here is x2, x1 minus x0, x2 minus x0 for the first entry in the denominator I am talking about. Okay. For the second entry, you have x3 minus x1. For the third entry, you have x4 minus x2. And for the fourth entry, you have x5 minus x3. Right? Okay. For the third order divided difference, you have skipped 2 in between. Okay. So you have 1 minus minus 2. Okay, and then you have 3 minus minus 1, and then you have 5 minus 0. Okay, now for the fourth order divided difference, so if I wish to find fourth order divided difference, okay, so I am again going to use these two values. So minus 81 by 24 minus 7 by 3 divided by, what will be in the denominator? Fourth order, 4 minus 1 is 3. So you are going to skip 3 and starting from x0. So x0, x1, x2, x3, x4. So it must be x4 minus x0. You are going to skip between 3 values. So 1 minus, so 3 minus minus 2, that is 5 in the denominator. For the second entry, what you have is 3 minus minus 81 by 24, that is the numerator, divided by, now you are going to skip again 3, right, starting from the next value from the starting base. So you have started with minus 2, so next value starting with minus 1. So you are going to skip between 3, that is going to be x5 minus x1. Okay, so you call this some value. So then for the fifth order divided difference, you are going to use these two. So fifth order, you are going to skip the 4 values in between. So if I call them this something like, let's say this is G1, and let's say this is the next entry is Z2. So G2 minus G1, so you are going to skip in between 4 values. So minus 2 you are starting, okay, minus 1, 0, 1, 3. So there are 4 values of 5 minus minus 2. Okay, means x5 minus x0. Okay, so this is how you will create a divided difference table for a given table of a data set. Okay, right. So then what you will have, so you are going to feed the values in the Newton's interpolating polynomials. So what will be the C0? So you have the C0 is as follows. C0 is this. Okay, then you are going to look in this direction, the downward direction, and that this will give you all the required values. So here this is C0, first zeroth divided difference. This is C1. Okay, this is C2, this is C3, this is here C4, and this is your C5. Okay, so by substituting them in the Newton's polynomial, you are going to get the Newton's polynomial. Okay, and you have the x0, x1, x2, x3, x4, x5 values are here. Okay, so I hope it is clear from these tables that okay, how to calculate the divided differences. Okay, and which is very easy when you are dealing with the table. Not that in the following in the in this scenario we have not assumed that the nodal points are equally spaced. Okay, so if they are here, so if you look at the length of the each interval, so minus 2 to minus 2 to 1, what is the length is, so if you see the distance between minus 2 and 1 is 3. From 1 to 0, if you look at the distance is 1. From 0 to 1 it is 1, but from 1 to 3 it is 2. From 3 to 5 it is 2. So they are arbitrarily spaced. Okay, so they are not equally spaced. Okay, so for the equally spaced nodal points, if you have equally spaced nodal points, then we have a very formulas called Newton's forward interpolation and backward interpolation. Okay, that we are going to learn in the next lecture. Okay, right, in the next lecture. Okay, right.